Now, it's very unfortunate that we often hear that a certain building under construction or a certain bridge under construction collapses. There are reasons for that. And those are exactly the kind of reasons which we must investigate. We must be aware of what could cause an accident and try to make sure that accidents do not happen. Accidents are accidents. Sometimes they will happen. They are unforeseen. They are unplanned. Nobody plans for an accident. But there has to be a method in which we will or we can control accidents, make sure that accidents don't happen. There have to be methods by which we can evaluate one company or another in terms of its accident record, in terms of its safety record. So these are the kind of things which we'll talk about when we go through this module on safety management. When it comes to legal aspects of construction, what will we talk about? There are different agencies involved in the project. It could be the client, it is the designer, it's the contractor, it's the investor, it's the regulator, and so on and so forth. Now, if there are multiple agencies involved in the project, what should be the kind of documentation which will define the roles and responsibilities of each of them? And that is what is basically a contract. We must remember that these are large projects spanning over several months or years, involving hundreds of people, sometimes thousands of people. And therefore, unless there are written documents which define the roles and responsibilities, which define the kind of work they do, it's very, very difficult to manage a construction project. That's one part of it. The second part of it is that there's a large amount of money being used. And we have to make sure that the money is being used in the best possible way, in the most effective way. There is no wastage of funds. And if there's any waste of resources by any of the stakeholders, there have to be ways and means of penalizing that particular agency. So all that part is laid down in contracts, and that constitutes the legal aspects of construction. And what we will be talking about is claims, disputes, arbitration, project closure, role of third parties, legal cell in a construction company, and labor laws. Now, labor laws is also a very important part of a construction manager's job. As a construction manager, one must be aware of the rules that govern employment of labor in terms of the facilities that they need to be provided, the kind of protection they need to be provided, the kind of facilities and so on. So this is what the course will contain. As far as assignments in this course are concerned, there'll be lots of assignments because obviously being a width course, we will not be able to cover many of the keywords that we talked about in any detail. So there will be just the definition given in this lecture, and then maybe we'll ask you to develop it on your own. So basically what I've thought is that we'll divide the assignments in this course into two parts. One would be normal assignments for submission, where there'll be grading and solutions will be provided, and we'll probably have a discussion in the discussion forum and so on and so forth. But apart from these assignments, there will be what I call and not answer. There will be no grade. Interesting and important for you. Try to see if we can discuss them. And obviously, we'll not be able to provide any solutions because
12 steps of construction. Once the construction drawing and other related documents have been completed and approved by the authority in jurisdiction, the project will then be awarded to a contractor by the client through a consultant. In this period, the construction of the proposed project will begin. Construction can be summarized into 12 stages. 1. Clearing of the ground. To begin the actual construction, the clearing of the ground from where the location of the project will be built is the first thing to consider. The construction personnel task is to free the construction site for any obstruction and debris that may obstruct and delay the construction. The temporary facilities such as engineer's office, labor's quarter, material storage room, temporary water, and electric supplies and other related facilities should also be constructed prior to the start of work. A site perimeter fence should also be constructed during this period. 2. Site layout and staking. This activity involves the setting of the reference points in a form of construction grid lines and marking off the gate level. This is performed to ensure that the grids have been set up on site according to approved plans. The reference point should be marked properly and should not be disturbed throughout the course of the construction. Grid lines according to the approved drawing should be laid out prior to construction. Depending on the complexity and size of the project, the construction grids can be laid out through the use of theodolite or related surveying instruments. A more traditional way of the layout of the construction grid is popular to use for small projects is through staking using batter board and strings. Batter board are temporary wooden frames used to suspend the strings. The strings are the representation of the grid lines at X and Y directions according to approved plans. These will serve as a guide throughout the construction, so it is important to fix a reference line in both directions to be used once the grids have been placed when needed in the construction. 3. Excavation. Once the layouts of construction points and grid lines have been completed, the excavation works begin. The excavation depth depends on the recommendation by the Soil Investigation Report. But it is safe to say that the minimum excavation level for the footing to rest should stick to 1 meter below the gate level or the 0.00 level. Excavation works is a massive activity, therefore a proper caution should be observed during this stage. In the event that the excavation needed is along with the neighbor's existing structure exceeding 1.20 meter from your proposed level, then shoring support is recommended. 4. Compacting and laying of PCC. Compacting of the excavated surface should perform once we reach the desired excavation level. A layer of crushed gravel is then to be added during the compacting. In a standard compaction procedure, the final compacted layer should be checked in order to reach the desired degree of compaction to not less than 95% of the maximum dry density. It is then in this stage that an anti-termite treatment on the ground should also be considered. The laying of PCC or plain concrete cement should follow afterward in preparation for rebar works. PCC is usually composed of a 10 mm thick lean concrete for the footing rebar to be laid evenly level. 5. Foundation rebar and column starter bars. Once the laying of PCC has been set up, the rebar works for foundation and any foundation beams are the next activity. In this stage, the reinforcement of foundations is being prepared according to the structural schedule along with its formworks. The proper and standard concrete cover should be observed during this procedure. Starter bars for columns should also be installed accordingly before concrete pouring. 6. Concreting of foundations and column rebar installation. Concreting of foundations has to come next after the rebar works. The concrete to be poured should be properly vibrated for the concrete, especially the aggregates, to fully spread into the footing. Installation of column reinforcement on the previously installed column starter bars should be continued. A proper concrete cover should consider before closing the formworks. For substructure columns, an additional concrete cover of at least 50 mm has to be considered up to plinth level to protect the rebar for possible corrosion due to sulfate attack. 7. Concreting of column and bitumen paint applications. Once the concreting of stub columns has been completed, give time for the concrete to dry completely and apply at least 2 coats of bitumen paint for both footing and stub columns. Bitumen paint helps in absorbing moisture due to the soil to prevent seepage into the substructure concrete. 8. Setting up perimeter blocks. Install solid blocks along the perimeter or the edge of the proposed project. This is to establish a boundary between the inside and outside edges of the project. It is also helpful when the difference of inside floor finish level to outside pavement or ground level is significant. 2 coats of bitumen paints should also apply afterward. In some cases, perimeter blocks are optional, especially for areas where the soil characteristics are too firm. 9. Backfilling and compacting. Once the substructures like foundation structures including the solid blocks have been installed completed, backfilling and compacting should take place. Backfilling and compacting should be done partially to make sure that the required degree of compacting has been met until reaching the bottom of the tie beam level. 10. Tie beam reinforcement, grade slab, and concreting. Preparation and installing the tie beam reinforcement as per the approved drawing is the next step to consider after the backfilling and compacting. Formworks with standard concrete cover are also included in this stage. Once the reinforcement works have been completed, we can start the concreting. Installing of grade slab mesh and concrete work is then to be followed. 11. Rebar works and concreting of columns. At this stage, the substructure component of our project has been completed. It is now time for the project to go up. The next thing to consider is the rebar works, shuttering or formworks and concreting to be done. Prior to concreting, we see to it that the columns follow the structural schedule. The formworks should be vertically level and a standard concrete cover has to maintain prior to the closing of forms. 12. Beam and slab works. Once the ground floor columns have been cast, it is time to prepare the project for beams and suspended slab reinforcement activity. Like any other structural members, beams and slab reinforcement should be followed strictly. Shuttering or formworks for slab and beams should be properly anchored and checked prior to concrete pouring. Step 11 can be repeated accordingly until such time that the structural frame or the core and shell of the structure has been completed. The architectural finishing works are then be followed. Thanks for watching.
And today is lecture number 2, where we'll talk about the interdisciplinary nature of modern construction projects. Traditionally, construction projects were seen to be largely civil engineering projects. Now it's not so anymore, and that is what we will see through an illustrative example of metro construction. Now, before we get into a discussion on metro construction and the example and the issues involved and so on, let's go over the course once again. Urban built environment in the 21st century is focusing on various infrastructural aspects such as commercial buildings, malls, metros, airports, roads, and rails. And accordingly, modern infrastructure projects are getting increasingly interdisciplinary or multidisciplinary in nature, in that they span several disciplines of engineering. So most of our treatment here will be with a civil engineering bias, but we will not try to use a lot of knowledge of technical civil engineering or the specifics of civil engineering, but of course we will have to borrow from civil engineering issues. As a manager of these projects, a certain level of awareness and knowledge of diverse issues is required. Needless to say, depending on the stage of construction of a project, the project manager could be from civil engineering with a civil engineering background, or it could be from a mechanical engineering background or an electrical engineering background and so on. It's important to understand that in the construction phase, at different points in time, different activities are predominating. In the initial parts, there's a lot of civil engineering that goes on. As we go along in the project, perhaps depending on the nature of the project, mechanical engineering and electrical engineering, these kind of issues become more important. So organizations tend to change the project manager from time to time, depending on the expertise. Similarly, having said that, even when civil engineering activities are going on and the project manager is a civil engineering background person, that person should have a basic understanding of the mechanical and electrical engineering issues and so on. So that is what is the backdrop against which you should try to understand our treatment of construction projects. So now coming to interdisciplinary nature of projects, let's take some illustrative examples like metro construction or an automobile plant or even a transmission line project. So if we broadly divide the engineering domains as civil, mechanical, and electrical, of course, there could be other disciplines also involved depending on the nature of the project, depending on the stage in which the project is, and so on. If it's a metro construction, there are definitely civil engineering aspects, mechanical engineering aspects, and electrical engineering aspects. Similarly, in an automobile plant, once the plant has been commissioned and is in operation, then it's not necessarily a great civil engineering operation. So it's a mechanical engineering operation with controls, electrical engineering, software people. All these people come into play as far as management of that operating plant is concerned. But at the time of construction, it is largely a civil engineering activity. In the case of metro construction, however, even during operation, the civil engineers continue to play a very important and a vital role. It's not only metros, but in fact, if you think about it, if you look at the railways for that matter, you will realize that even in the operating phase, the civil engineers have a very important role, but the training and the kind of skills required is not necessarily those required at the time of construction. At the time of operation, you require skills in non-destructive testing, monitoring, repair, and so on. The skills required is different, but the background is the same. Now, if you look at the third example, which is cited here, the transmission line project, an electrical company can decide to lay a transmission line from point 1 to point 2. There will be electrical engineering issues, of course, because what kind of power to be transported, what kind of towers to be used, what height the towers will be, and so on. Those are issues which need to be resolved in consultation with the regulatory authorities and so on. But once the electrical part of it is completed, the loads and so on are handed over to civil engineers for structural design and so on. There is the construction part where the towers are erected. And once the towers have been erected, civil engineers are obviously not the best people to identify the kind of wires to be used, the kind of fabrications to be done, or for that matter, the kind of laying of the lines is concerned, or substations on the way. The construction of the subway is a civil engineering issue, but the equipment that goes into the substation is definitely not civil engineering. So the project manager who manages these projects has to have some understanding of all the different facets of the project. So now getting back to our example, which we will deal today, is metros. So now, if you look at metros, we need to break it down. It would be easier if we break down a metro system into components and then try to see what kind of expertise would be required to manage or to be able to implement a particular part of the construction. So now there are different ways of looking at this breakdown. One is to look at what are the different components in terms of, let's say, the stations. So there are stations where the metros or the trains, they come, they stay there for a certain amount of time, and therefore the kind of issues that go into the planning of a metro station would include movement of passengers coming in and going out, the movement of trains coming in and going out. If you look at the planning of stations, primarily the issue is movement of passengers, embarking and disembarking, and how we will transport them from the outside of the metro area. So if you look at any metro station, you are approaching the metro station from an area which is not really metro. So first thing is that the passengers will come into the metro area, then they'll come to the platform and take the train. On the other side, people will disembark from the train, get out of the platform to the station area, and then leave the metro area. So one of the parts of planning and construction of stations is the movement of passengers. Similarly, there is this issue of trains which are coming in and going out. There is the related signaling issues and so on and so forth. In both these cases, there have to be appropriate provisions for safety measures or emergencies that may arise. So if there's a fire in the station, there have to be emergency evacuation systems in place and so on, and that goes into the planning and construction of stations. Moving from there, there are maintenance yards where the coaches and the locomotives are maintained. That is, they are overhauled, some kind of minor repairs are carried out and so on. So again, if you look at the movement of trains, so the trains move on tracks which are laid on sleepers, and the load is then transferred to the ground. So apart from the coaches and the engines, everything is basically a civil engineering domain story. Whether it is the tracks, whether it is the sleepers, whether it is the ballast or whatever goes on in transferring the load to the ground. So as far as a maintenance yard is concerned, depending on where the maintenance yard is, somebody will tell you that, okay, this is the length of the trains which need to be parked so that they can be cleaned. But the layout and the civil engineering infrastructure that goes water supply there, removal of wastewater from there, and so on, that remains a civil engineering domain issue. Similarly, if you look at operations rooms and offices, so there is the need for having operations rooms, offices, where different people associated with the metro operations will work from. And that has to be, again, planned. Continuing with the story, there could be tracks. And now if you just pause to think about some of the metro systems that you may have seen, you would realize that the tracks could be underground, or they could be on grade or above grade. Now, depending on whether the tracks are underground or on grade or above grade, different aspects come into play. And as engineers, we need to understand the issues so that we are able to handle them as they come during design or during construction. A proper understanding of all these things helps us plan the system better and ensures that as we go along in a construction project or in the project of metro construction, we do not have to make sudden changes. Another way of looking at some of these systems would be, let's try to divide them into civil structures. Now, if you look at civil structures, there could be buildings, operations rooms, and stations can all qualify as buildings. Similarly, there would be tracks, there would be tunnels. If the track is underground, we'll have to make tunnels. There would be bridges. Now, bridges can have two functions here. One would be crossing a river or any other obstacle. The other way of looking at a bridge would be all kinds of track which are above grade. They could also be looked upon as bridges in one form or the other. So depending on what view we take, these are basically inclusive of all kinds of above grade structures which are designed to carry the metro above ground. Then there is rolling stock, which is definitely not a civil engineering story, and that consists of coaches and the locomotives. And besides that, there are controls and monitoring systems. There is the entire power network which has to be laid down, and so on. So depending on which way we break down a particular system, we'll have a better understanding as to what is the kind of expertise which is required for executing a project. Now, execution of the project does not necessarily mean only on-site operations. If it comes to rolling stock, for example, these coaches and locomotives have to be procured. When it comes to buildings or tunnels, we need to decide what kind of material we will use. And that decision is also an engineering decision and needs to be taken with proper planning and technical issues being kept in mind. Now, here is an example of a station. And you can see that apart from the train and the platform, there are so many other things which are a part of the station. There are signages which tell people which way to move in case of an emergency, which way is the exit. There are signages to tell people how much more time to the next train. There could be signages relating to whether a train will stop at that station or not, what is the next stop for that particular train coming into the station, and so on. So all these things need to be properly planned, included in a drawing, which is used for communicating among engineers from different walks of life. Similarly, if you look at a maintenance yard, here is a place where you need a lot of water supply, a lot of systems to make sure that certain amount of testing can be carried out. So now here is a maintenance yard where you need facilities which are required to maintain the coaches and the locomotives. That could include water, that could include some amount of power. That would definitely need some amount of lighting depending on where the yard is, and so on and so forth. In operations rooms and offices, of course, you need a different setup, and that needs to be planned. When it comes to an underground track, which is essentially a tunnel, we have to understand what are the issues that go into the planning, design, and construction of a tunnel. That would include things like lighting, ventilation, emergency communication, the kind of slopes that you have to have. You have to make sure that there is no leakage of water from outside into the tunnel. What are the kind of emergency evacuation plans from the tunnel, and so on. In fact, it's sometimes important and required that along with the tunnel, we run what is called a service tunnel, which serves as a parking space or which serves as a place where people who may have to evacuate from a train in the case of an emergency can leave the tunnel and assemble in a service tunnel. The service tunnel also serves as an area through which service lines such as water and power run in addition to the space within these tunnels. When it comes to an above grade track, of course, the situation is more or less similar to that of a bridge. And you can see that we have the standard bridge piers and the slab and so on, which is designed for the kind of loads that is to be carried by the structure. So now other components in a metro system would include power supply, signaling, ticketing. We have to make sure that there is no rush of people at ticket counters and at places where there are wickets to check the tickets when the passengers are coming in and the passengers are going out. Then there is a very important component of emergency management. It could arise on account of power failure. It could arise on account of a terrorist threat and any kind of an unforeseen event. It could arise on account of an accident where a derailment has occurred or where the trains have collided and so on and so forth. Apart from these, now once we are talking of these things, like I mentioned, there are issues related to lighting, ventilation, communication, air conditioning, and power supply, besides firefighting. All these plans have to be put in place so that the metro system can be designed. Now, it's no single engineer's cup of tea to be able to put together or have all the knowledge that is required for lighting and air conditioning, communication systems, and so on. So different people come together